Hi friends, welcome to our channel. In the previous session, we had discussed about ordered rule list. That is how to create a learning order rule list. Now, based on the concept, we will consider an example and construct a rule list. This is the given data set. The given data set contains, this is the given example. This contains 4 parameters: length, gills, beak, teeth. That is the 4 features. And 5 P12, P5 are 5 positive instances, N12, N5 are 5 negative instances. We have 5 positive instances and 5 negative instances. So, initially how many number? 5 positive and 5 negative. From these 5 positive and 5 negative instances, how they are categorized? That is, in the total, suppose if length is equal to 3, how many number of positives and negatives? If length is equal to 4, if length is equal to 5. Similarly on gills, if yes or no, beak, yes or no, teeth, many or few. We will categorize each and every one. That means these are the different categories. First I am writing, if length is equal to 3. If length is equal to 3, how many number of positives? 1, 2. 2 positives and 0 negatives. So length is equal to 3. 2 positive, 0 negative. Now, length is equal to 4. If length is equal to 4 means 1 positive, 1, 2, 3 negative. 1 positive, 3 negative. If you are writing in this fashion, it is very easy to construct the tree. If length is equal to, so it is very easy to construct the rule. If length is equal to 5 means 1, 2. 2 positives, 1, 2 negatives. So 2 positives and 2 negatives. So the length is completed. Now move to gills. Gills has 2 options. One is gills is equal to yes. Gills is equal to yes means we have 0 positives. 0 positives. And how many number of negatives? So 4 negatives. And gills is equal to no. Gills is equal to no means we have 5 positives and the remaining 1 negative. Now move to the third feature, beak. Some beak is equal to yes. 1, 2, 3, 4, 5 all 5 are positive. 5 are positive and negatives 1, 2, 3. 3 negatives. And weight is equal to no. No means it contains 0 positives and 2 negatives. 0 positives and 2 negatives. Finally, teeth. Teeth is equal to many. 1, 2, 3. 3 positives. 1, 2, 3, 4. 4 negatives. And teeth is equal to few. 2 positives, 1 negative. This is the initial construction. That is, initially all the instances are considered. Initially all the instances are considered. Now what is our first step? We are defining a rule such that most of the instances have to be eliminated. Here we are considering only the positives. Remember, our aim is to consider the positive instances. So which literal, all these are called literals. Which literal is to be considered? So observe, similar to decision trees. Observe the gills is equal to yes contains 0 possible. That is, this is a pure class. This is a pure class. Almost, actually we have 5 negatives. It contains 4 negatives and the positives are 0. That means whenever gills is equal to yes, obviously the class is considered as a negative class, because it does not contain any positive. So my first rule is, suppose here I am writing the rules. My first rule is, if gills is equal to yes, then class is equal to negative. Because based on the purity, all the positives, if it is yes, we have 0 number of positives and majority class is negative. So obviously we are considering as all are negative class. Whenever this rule is applied, whenever this rule is applied on the set of instances, we have to reduce the instances. That means, suppose if length is equal to 3, that means we does not need any negative class. If length is equal to 3, so length is equal to 3, this one. Here gills is equal to no problem. Length is equal to 3, gills is equal to no problem. So we have only 2 lengths. Then what is the case? If length is equal to 3 and gills is equal to s. So the number of instances, that is the number of instances 2 plus 0 minus. If any changes? No. After modifying the tree, you got it? Again I will explain. If gills is equal to s, then the class is negative. We doesn't need any negative class. So length is equal to 3, here gills is no. This is included. Length is equal to 3, gills is equal to no. This is also included. That is, whenever gills is equal to yes, that statement is eliminated. Similarly, for length is equal to 4, gills is equal to no, this is included, and we have only one positive. So this is a reduced fraction, one positive. If gills is equal to yes, so in length 4, 2 are eliminated. Only we have length is equal to 4, 3 statements. But by using this S condition, these N2 and N4 are eliminated. We have only N5. That means only one negative, one positive and one negative. You observe the number of negative instances are eliminated. Similarly, for length is equal to 5. So all 2 are placed because gills is equal to no. And in this length is equal to 5, we have 2 instances. All these are S cases. Means these 2 are eliminated. That is simply 0 negatives are considered. Similarly, gills is equal to yes, the statement completely removed. That is, that split is already considered. That literal is already considered. Now gills is equal to no. We have 5 statements. All these 5 statements are included. 5 plus yes. These 4 are removed. Whenever it is yes, we have to remove only one negative. 5 plus 1 negative. Similarly, bake is equal to yes. In bake is equal to yes, check the case of gills. So all positives are included because in all the cases the gills value is negative. All positives are included. Suppose come to the negative. Bake is equal to yes. Gills is equal to yes. This statement is removed. This is also removed. Suppose come to this one. Bake is equal to no. So this is not required. We require only this one. Bake is equal to yes. Here gills is no. Only one negative is placed. Now, bake is equal to no means we have 0 positives. Bake is equal to no means this one. For this one, gills is equal to yes. Eliminate this statement. Bake is equal to no. Gills is equal to yes. This statement is also eliminated. 0 positives and 0 negatives. Okay. Bake is equal to no. Gills is equal to yes. And teeth is equal to many. Teeth is equal to many means 1. Gills is equal to no. That one is included. Many no included. Many no included. 3 positives are included. Come to negative. Many yes, it is removed. Many yes, it is also removed. Many yes, it is also removed. Many and yes, it is also removed. So there is no many. All the negatives are removed. Finally, teeth is equal to few. Few no. These 2 positives are included. Few no. One negative is also included. That is what I am doing. First my rule is gills is equal to yes. Then in all the cases, whenever gills is equal to yes, that class is negative. That is, we are removing that class. that instances from our example. Now it contains how many number? 5 positives and 1 negative. That means after performing GILS is equal to S, the 5 positives are available and these 4 negatives are eliminated. That means we have 5 positives and 1 negative is available. Next, define one more rule. Suppose the rule is, if teeth is equal to many, then, so which one we are assuming? Why we are assuming teeth? Suppose observe this one. We are defining, suppose 0, 0. There is no use of this one. There is no use of this one. Consider this one or consider this one also. If teeth is equal to many, we have 0 negatives and 3 number of positives. So, if teeth is based on homogeneity, teeth is equal to many, then we are assumed as the class as a positive. Whenever we are treating the class as a positive, how many number? 1, 2 manys. So only 2 positives are remaining and 1 negative. Only 1 negative are available. So that means 2 positives and 1 negative. Suppose 2 positives and 1 negative. So again same procedure, divide these terms. Again 3 positives, 2 positives and suppose the bake is equal to S. Okay, bake is equal to S and we have 1 negative. Similarly, bake is equal to no. If bake is equal to no means this is a completely positive class. So no need to calculate. Similarly, teeth is equal to many. We are calculating this one. Teeth is equal to few. So 2 positives, 1 negative. The similar approach. Again, so the procedure is a similar fashion. The procedure is in a similar fashion. GILS is equal to S. Next, I am considering length is equal to 4. I am assuming my class as a minus class. If length is equal to 4, my class is the minus class. Again, some of the terms are eliminated. And finally, so here I am writing in this fashion, else if, yes. That means all the rules. Else means if length, automatically final case, else the class is the positive class. Here the procedure is very simple. Step by step we add the rule and eliminate some of the statements. We add the rule and eliminate some of the statements. Now one more point we have considered is, these are, suppose second rule is compulsory preceded on the first one. Third one is compulsory depends on. Fourth one is compulsory depends on. And again if length is equal to 4, again the terms are reduced. And finally I am constructing the tree. Now finally this is the tree. Observe, if GILS is equal to S. In the previous step I am step by step eliminating. If GILS is equal to S, 0 positives and 4 negatives. The class is predicted, that is the completed. If teeth is equal to many, means we are getting, suppose on GILS, if it is no, we are moving to teeth. On teeth we are getting, suppose 3 positives, 0 negatives. 3 positives and 0 negatives on teeth. Again, we are moving to third case, length is equal to 4. If length is equal to 4, 0 positives, 1 negative. And length not equal to 4, and the last case remaining the 2 are positives. That is finally we have 2 positives and 1 negative. We have 2 positives and 1 negative. See this one, 0 plus 2, 2 positives and 1 negative. This is the final tree. And this is the rule list. Here there is no need to write the rule list in the same order. That means we are moving to this case by considering this case only. We are moving to this one by considering this one only. We have to write in an unordered fashion also. That is, one rule does not depend on another rule. Suppose I am erasing this one. How we are writing this same rule? And the last one is, if GILS is equal to S, then class is equal to minus. Okay, fixed. If, that is, one rule does not depend on another rule. If GILS is equal to no, if we are moving else block means automatically GILS is equal to no, and length is equal to, and teeth is equal to many, then class is equal to positive. If these two conditions are failed, that means gills is equal to no and teeth is equal to few, many opposite is fails, and length is equal to 4, then class is equal to minus. If and all the cases are failed, if all the cases are failed means gills is equal to no and teeth is equal to few and length not equal to 4 means then class is equal to positive. This is the way. So, and finally the simple step is, step by step we are add a rule. Based on the rule, eliminate some of the positives and eliminate negatives. Most probably we have to make concentration on elimination of negatives. This is the creation of a rule list. Thank you.